Yeah, that's fine.
Okay. All right. So let's get started. Um, so going back to yesterday, we were looking at modeling linear functions. So we learned how to write the equation using 2 points, and the main things we discussed were how to find the slope of the line, and then how to write the equation of the line in point in slope intercept form, which is y equals mx plus b. And there's also something else, this point slope form, which I didn't really use very much, but you could use it in place of slope intercept form if you want. I just find slope intercept form a little easier to interpret when I look at the actual equation as opposed to this. But this has its uses, and in future classes, you'll see this one sometimes preferred over the slope intercept form. Kind of depends on the activity. In this class, I would probably say that slope-intercept form's a little more useful than this form, but that's debatable. So anyway, we saw questions where you were given 2 points. You had to then identify the slope, and from there you can make some judgment calls about what happens at a different value of x or a different value of y. And you can find, given an x, you can find the missing y, and given a y, you can find the missing x using the equation of the line. And we saw things like that pretty much throughout the period yesterday. So today it's more of the same. The thing that's a little different is we're going to use two things. One where you're actually given the equation, and then one where you're giving a set of data. And I'm going to show you a couple of ways in which you can do this. I'm going to do the example by hand at first, and then I'm going to use technology for doing it the second time. So this question is probably going to take us a little bit of time. So let me get started. Let me just write down the things that we know that we need for these questions, and the things that we know that we need for questions like these are the tools that I showed you on the other slide. So we know that for this we need m equals y2 minus y1 over x2 minus x1. That just gives you the slope, right? Given that you have two different points. You could also use the other point slope form, y minus y1 equals m parentheses x minus x1. That's fine too. Okay, this can be used. And I, again, for today, like yesterday, I'm going to answer my questions in y equals mx plus b form. And that's by preference. You can answer it this way if you want instead. It's kind of up to you. So let's see here. Let me change colors. So let's take a look at this problem. This problem has two components. It's got a lot going on. Uh,
Mr. Busy.
yes, yes.
So this example is just like the one we did yesterday, right?
It is, but there's 2 things here. So they're gonna model you're gonna see that when I read the example, the question's about 2 different prom venues. Like, one location charges you, and they give you the function of which they charge you. And the other location, they tell you, like, "Here's the price based on how many people. Here's the price based on how many people." So they present the information to you in 2 different ways. And I believe we're gonna be asked to figure out, like, what's the cost per person depending on the venue, or
Like
when would
statistics.
yeah, pretty yeah. So, but it's light. It's not nowhere near to the level of the other class. This is much
Okay.
the college now class is on another level than this.
Okay.
Okay, this is definitely you should feel the difference, right, between this and the college now course. The college now course is much tougher. Um,
Hmm.
you're gonna see the question is much more simple. Okay, two prom venues charge a rental fee plus a fee per student. So basically, both of these venues, no matter which one you pick, there's a flat fee. So if you book the venue and nobody shows up, there's still some money that you have to pay, like a rental fee, right? Regardless of how many people there are. So two prom venues charge a rental fee plus a fee per student. Okay. The table shows the total cost for different numbers of students at Lakeside Inn. So Lakeside Inn's down here. Okay. And basically what this says is if 100 students show up, your total cost is 1500. If 125 show up, the total cost is 1800, et cetera, et cetera, et cetera, right? If 200 show up, the total cost is 2700. Um, you have to be careful here. You might get tempted to divide, but that you can't do that because the total cost is not just based on the students. There's also some flat fee. There's a rental fee, which I don't know what that is right now. They don't tell us. So we're gonna figure that out in a few minutes. The total cost y, so y is the total cost in both, in either model, of X students at Sunview Resort is represented by this equation. So Sunview, they don't tell you, they don't give you any discrete values. They just tell you what the function that represents the total cost is. That's all they tell you. Which venue charges less per student? Okay, so not which one charges less, which one charges less per student. That's a specific question. Um, how many students must attend for the costs to be the same? So that's like part B. How many students would it take for the Sunview charge and the Lakeside Inn charge in terms of total charges? How many students would it take for those two things to be equal? So when that happens, if the two things are equal, we'd be indifferent about which location, right? The prices would be the same, wouldn't matter. So we're gonna figure that out. But first things first. Let's try to figure out the cost per student. That's the first thing. Which venue charges less per student? So I don't know. I want to know which one charges less per student first. We're only going to work on this for now. Okay, we're not going to worry about part B yet. So which venue charges less per student? Well, let's see here. Sunviews is much easier to work with, and some people in this class might be able to just look at this and answer the question in 2 seconds. And if you can do that, then that's great. Okay, that's great. But for those of you who can't, who don't see what the answer is right away, who it's not obvious to, that's okay too. No reason to worry. What we can do is this: we know that y is the total cost, right? And x is the number of students. So let's do this. Let's say nobody shows up. 0 students. No one shows up to this prom. Let's see what the fee would be. So y would equal 10 times 0 because x is 0 because nobody's coming, no student show, plus 600. If we work this out, we know that 10 times 0 is 0 and 0 plus 600 is 600. So the total cost if nobody showed up would be 600 bucks. Okay? So that's the total cost if not a single student shows. Let me see what happens if one student shows. 1. If one student shows, that means x is 1. So I'd say y equals 10 times 1 plus 600. If that's the case, 10 times 1 is 10 plus 600 is 610. That's my dollar sign symbol there. So 610. So by adding one student, the price went up $10, right? Let me just go to two students. Now, based on this, since it went up $10, I believe each student's going to cost $10, but let's be sure. So if we had two students go, if two students show up, that means x is 2. So y would equal 10 times 2 plus 600. And if you work this out, that's 10 times 2 is 20, plus the 600 is 620. And you can clearly see, right? The price is increasing by $10. As we keep adding students on, for every additional student that shows, the price is going to go up or increase by $10. So it appears as if the price per student, the per student price is $10. So the cost per student is 10 bucks. Okay. Now, did you have to do all this work over here? No. You could have probably figured it out just by looking at the equation. You can see that the cost that's changing is it's 10x, right? Every time x increases by 1, this value is going to go up by 10. So when it's one student, it's $10. When it's two students, it's 20. When it's three, it's 30. When it's four, it's 40, right? So every time you add a student on, the price is rising by $10. This 600 right here, right? This is your y-intercept. That's fixed. The $600 will never change. If five students show or 500 students show, this 600 is still going to be 600. It's not going to ever change. So that 600, that must be the rental fee. All right. It's a flat fee. It's something that it doesn't depend on X at all. Okay. The 10 depends on, right? This depends. As X changes, this 10 is going to change. So every time you put raise X by one, this right here is going to raise by a value of 10. I hope that makes sense. Are there any questions on that? Anything?
No.
Okay. So yeah, and that's why slope, the rate of change, slope in this question is is basically um the change in money over the change in the number of students, right? As the number of students increases, as X rises, Y rises with it. If you were to graph this equation, 10x plus 600, okay, it would look something like, I showed you this in my second period, I forgot to graph it. If you would graph this thing, okay, it would look something like this. This is not drawn to scale, obviously. Okay, and this would be 600 right here. Okay, so if no students show, the cost is 600. If one student shows, it's 610. If two students show, it's 620. If three, it's 630, etc. Okay, you'll notice I didn't make the line go continue this way because that would make no sense. Because in real life, you can't have negative students. That's impossible. So it's got to be zero or bigger for the x-axis. So this line ends right here. Okay, just it continues this way only. Okay, so that's Sunview Resort, and that's pretty easy because we just look at it and tell it's 10. So that's fine. Um, the problem is here, okay? This is the issue, is the Lakeside Inn. Let me change colors for Lakeside Inn, not to confuse anybody. Let's do Lakeside Inn in blue. So Lakeside Inn's a problem because I don't know, I don't have an equation. I don't have this. So I would like to have y equals mx plus b. I would like to have that. If I could have y equals mx plus b, once I find M, great. Then I know what the cost per student is, and when I find B, I'll know the rental fee. Okay, so I want to find these things, and then I can answer A. I can then answer which venue charges less per student. So I got to find M. Well, finding M is not too hard. We did it yesterday. I can find M using this, right? Y2 minus Y1. I can find M using Y2 minus Y1 over x2 minus x1. And the thing now is, well, how do I know which x's and y's to pick? Well, the answer is it doesn't really matter. It's up to you. In my other class, I chose 100, and I chose this. I chose 100 and then 1500 because this is an x and this is a y, right? So they go together. So I chose this one, and I chose this one here. Let's choose a different one. Let me choose this one. I'll choose 150 and 2100. Okay, so I'm going to choose those. So if I choose those, and again, it's up to you. You can choose any two you want. It's up to you. Just make sure if you pick 100, you got to pick 1500. If you pick 125, you have to pick 1800 because you have to pick for any X you pick, you must pick the Y that corresponds. Okay, you can't, all right? You can't mix and match those. So this could be my X1, which means this is my Y1. This could be my X2, which means this is my Y2. All right, and then I just put everything into here and find the slope. So I'm doing 2100 minus 1500, y2 minus y1. So my m is 2100 minus 1500. That's y2 minus y1 divided by x2 minus x1, which is 150 minus 50. Oh, minus 100, excuse me. Let me fix that. And I do a little algebra. 2100 minus 1500, I believe, is 600. And 150 minus 100 is 50. So if you divide 600 by 50, you should get 12. Okay. So my M, I know now that my M is 12. And that's very helpful because that's my slope. That's the cost per student. When I take the 12, I could put it into here and I can say Y equals 12x plus B. So great. I know the cost per student now is $12. Okay. So in this problem, okay, the cost per student, and this is for Lakeside, okay, that's the cost per student is $12. Which question A was which venue will charge less per student? So Soundview, Sunview. So Sunview charges 10 and Lakeside charges 12 per student. So it looks like Sunview is cheaper. So Sunview charges, what is it, $2 less? $2 less per student. It's cheaper. Now I have to be careful with my language. It's cheaper per student. Okay, it's not necessarily cheaper. So Sunview charges $2 less per student. Okay, that's based on what we found here. That this is $12 and this is $10. So Sunview is $2 less per student. One thing I didn't do, you really want to find B. I don't like leaving that missing. I think I'm going to need it for part B anyway, because it says how many students must attend for the total cost to be the same. Well, I need an equation that's not done. So I have to find B. Finding B is super easy. You can choose any coordinate you want. If you choose a coordinate, you should be able to solve for B. So it doesn't make a difference which one you choose. I'll choose this one. You could choose any one here. So I'll choose this one. It doesn't matter. So if I choose this one, Y1 is 1500. Let me use below so it's consistent. So Y is 1500 and X is 100. This should allow me to find the missing B value right now. So I have 1500. I'm doing 12 times 100, which is 1200. And then it's so simple to solve for B. I subtract out my 1200, subtract out my 1200, and that's 300 for B. 300. So B is 300, just found by subtracting. So I'm just going to rewrite this. I'm going to rewrite the equation fixing B, putting 300 in its place. So I could say Y equals 12x plus 300. Okay, Y is 12x plus 300. There's the final equation. So just an observation. Um, Lakeside charges more money per person, but they only charge a $300 um, rental fee, whereas Sunview charges $10 per person, less per person, but $600 rental fee. So yeah, so you see what's going on here. You have a smaller rental fee from Lakeside, but a larger fee per student. So they're just the way that prices are structured are not the same. Okay, so which one's cheaper is going to depend on how many students are attending, right? I can look at this and see that this model is preferable. It's going to be cheaper if you have not many students showing up. Okay, if a small amount of kids are going to come, this one is better. If a lot of students are going to show up, then this one's going to be better. And we can model that in the calculator and see it. But what they asked you for here is how many students must attend for total cost to be the same. Well, the total costs are represented by Y, correct? Total cost is represented by y. So I want to know when this equation and this equation, when they're going to be the same. In other words, in math, the same means equal. So I need to know when 10x plus 600, that's the equation for SunView, is equal to 12x plus 300. So at some value of x, these two equations are going to be the same, meaning it won't matter which location we choose, the price will be equal regardless of where we go. So we have to solve this little equation here, which is pretty easy. Um, so to solve this equation, let's just get the x's together. And we can subtract 10x off of each side, and that will allow these to cancel. What is this, 600? Oops, so used to writing in green. 600 equals 2x plus 300. And yeah, I know you could have started this a bunch of different ways. It's up to you. Because I did it this way, now I have to subtract 300. And then these are going to cancel out. And 300 is equal to 2x. And to undo the multiplication by 2, we can just divide by 2 on each side. That'll get x by itself. And 300 divided by 2 is 150. So x is equal to 150. So what this means is if we get 150 students that want to attend this prom, the cost for Sunview and Lakeside will be the exact same cost. And we'll prove that really quick. We know that Sunview is 10x plus 600. We know that Lakeside is 12x plus 300. Oh, this is not essential. I'm just proving it. So let's prove that it's that what the cost for Lakeside would be. Sunview would be, sorry. So y equals 10 times, if you get 150, let's see what our cost is going to be. 150 times 10 is 1500. And then we have to add on the $600 fee for rental. And if we add those together, we have a grand total of $2,100. So if we get 150 students to show, the Sunview place is going to charge us 2,100 bucks. So it should be the exact same for this, right? So if we go to Lakeside, again, we have 150 students showing. So X is 150. Okay, so X is 150. If we multiply 150 by 12, we're going to get 1,800, 1,800. So if you multiply those, you're going to get 1,800. And now if we add 1,800 and 300 together, we're going to get a total of 2,100. And you can see, okay, that that's the exact same thing that you get if you attend Sunview. The costs are the same. So at $150, we don't really, it doesn't make a difference which place we attend. The price is going to be exactly the same. Okay. So that's basically how you'd work out this question. Are there any questions about this thing? I can't really think of anything else to say about it. You had to write the equation for each and then do a comparison of the equations. My opinion is that putting the equations in the slope intercept form just makes it a lot easier to compare them, where M is the price per student and B, the y-intercept in this case, would be the rental fee. Any questions?
No.
No.
Okay. All right, great. So, if there's time, I'll have you practice one of these by yourself. But I want to show you how to do a question where you can't do it manually. Okay. So let me show you what I'm talking about. So this question, the numbers were nice. Okay. This is not normal. This is not always the way it's going to go. I mean, in this question in real life, it makes sense because the price per person should be, it should be the same. It should, this makes sense in this context. But in other contexts, right? Let me show you what I mean. There are other questions where the model is not so nice. Okay. Often we see this in things like science, right? It's not always like perfect where you're going to get a perfect line. Okay. You can get something where it's almost a perfect line, but not quite. And that, you may have heard the term lines of best fit. Okay. A line of best fit, what it is, you basically have a bunch of dots, right? But the dots are close enough in a way where if you draw a line, the line is really close to those dots. That's called a line of best fit. Okay. Can you always do this? No, not every plot is going to have a line that's best fit. Let me show you what I mean. I'm going to just make up an example so you can see what I'm talking about here. If I had, I'm just going to make up a coordinate plane. Okay, maybe my dots look like this. Okay, now a line of, you can't get a line in there. It's going to be, it's just not going to work good. That's not going to be modeled by a line. Something like this might be better modeled by something that's like quadratic. Okay, so not everything can be modeled with a line. Sometimes if you try to put a line through this, it's not going to be good. You could do it, but it's just not going to be, it's not going to be very good. It's not going to be very effective. And I'm going to show you how you measure the effectiveness in a second. So, and it tells you here, data do not always show an exact linear relationship. Okay. When the data is in a scatter plot, show an approximate linear relationship, you can model that data with a line of fit. So sometimes the data might look like this. Now, if the data looks like this, you can get a line in there. Okay, that's pretty good. The dots are really close, right, to this line. So it's a pretty good line of fit. So again, you have to have the right type of data to do that. And how do you know if it's the right type of data? Well, that kind of comes down to observation. So you can create a scatter plot and you can look at it and say, hey, is a line going to really work here? And then if you put a line through it, you'll get a measurement that tells you how effective your line is. And I'm going to show you what I mean by how effective it is in a minute. Um, so there are steps here. Um, I'm not going to belabor this point because this is better. You really need a graphing utility for this, but I'm going to use some free software online and show you how to do it. On the state regions, you would use the TI-83. So if you were taking the exam, right, you would use a TI like 83 or 84 plus or whatever the case is, right? They give you these on the regions, they hand them out. So you would use one of those TI calculators to do this. So step one is to create a scatter plot. This is done by the calculator. Step two, sketch the line that most closely appears to follow the trend given by the data points. There should be about as many points above the line as below it. Again, you can do that with the calculator. Choose 2 points on the line and estimate the coordinates of each point. These points do not have to be original data points. We're gonna let the computer do that as well. Write an equation of the line that passes through the 2 points from step three. This equation is a model for the data. So this is if you wanna, they're giving me directions here to do it myself, which I really don't want you to do because when you do it yourself, it's just not, without the computer, it's not going to be to the accuracy that the state exam would want, right? We don't, and plus we live in a world of technology, so there's no reason for us to do it by hand. So we're going to actually just use the computer to do it. And fortunately, there are some software applications that will do it for you. You can just do a Google search like linear regression, and there'll be a bunch of tools that pop up, and you type the data in, and it does the calculations for you. Um, but I'm going to actually use Desmos and show you that way. Okay. Um, Desmos is not the best at doing this. There are probably easier ones online that are going to be easier to utilize than Desmos is. I'll show you how to do it on Desmos, although it's a little annoying. Okay. Um, the table shows the femur lengths. This is below. Okay. The data shows the femur lengths in centimeters. So there they are, and heights in centimeters of several people. So based on the femur length, I guess when the femur length is 40, the height of the person is 170. When the femur length is 45, the person's height's 183 centimeters. This person who has a femur length of 32 centimeters is 151 centimeters tall. So they just basically, what they do is they must have taken, I think there's 10 people here, three, four, five, six, seven, eight, nine, there's 10. They took 10 people, they measured their femur length, it's a bone. They measured their femur length and then they measured their height and they wrote down their femur length and then their height and they're trying to make a table out of they're comparing femur length to height. Okay? So when you do that, all this data gets plotted. So for example, 40 170, 40 right, 170 up, it's right there. 45 183. You can go to 45 and then up to 183. 32 151. A little right of 30 and then up to 151. Here it is, okay, etc. And they just plotted all the points, okay? From there, you could do what I did in the last example, do y2 minus y1 over x2 minus x1. You could pick 2 points that you want from here and do it that way. I don't want you to do that because this data is not exact. It's not like the other example, right? When the other example came out, it was nice. It was all exact. This one is not exact. So in this example, we're going to use technology, okay, to do it for us. So what I'm going to do is all this stuff has to go into Desmos, okay? So let me bring this over there. Okay, I'm going to bring this over to Desmos, and we'll take a look. Okay, let's go to Desmos. Okay, so what I did, I took the female lens, I made a table, okay, and I put the female lens in X, and then I put the height of each person, right? The corresponding value in Y. So I just typed all these in. Okay, when the person was 40 centimeter, with a 40 centimeter femur length, they were 170 centimeters tall. With a 45 centimeter femur length, they were 183 centimeters tall. I just copied the table is all I did. That's all I did. I took the numbers and I typed them in. Okay, after you type them in, now this is the part that's very annoying. So I'm gonna erase this and do it over. Okay, so you can see how I got this. So I know you guys know how to type the table in. To make a table, by the way, if you want to make a table, there's a little plus sign here for add item, and then you just click on table. Okay, and then when you're putting numbers, and I'm not going to use the one from above, but for let's say 7 2, you just keep typing the stuff in, and then you match it up. You can click over to the other side and put the corresponding y value, whatever that is, like 7 3 2, whatever it is. Okay, so you just make a table. Okay, make a table, and then type all the x's in, and then type all the y's in. Okay, that's what I did. So after I do that, I have all my x's and y's in. There's nothing really there. You're not going to see anything. So you want to do a linear regression. Doing a linear regression is a little annoying with Desmos. Um, you can, if you go to YouTube, there's a million people who show you how to do it. You can just say linear regression in Desmos, and you get like a million YouTube hits on how to do this. Um, Basically, what you do, you have to type in. I have this written down, Y, and then the I don't know what symbol you call this, but this. So Y and then this symbol. It's next to the one key on your keyboard. And then you have to do it's mx plus b, but because you're using x1 and y1, I forgot something already. It's y sub one, not just y. It's y sub one, y sub one, because I put my data in one. So y sub one is approximately. It's not an equal sign because when you do, it's really an approximation. Okay, it's a line of best fit, so it's not an equal sign. So y1 is approximately. I want mx plus b, so I want to do mx plus b. So mx, but I have to do x sub 1. It's not just mx sub 1, because I'm putting my data right in y1 and x1. So y1 is approximately mx1 and then plus b And now I get a line of best fit. And there's everything that I would need. Okay, it's all here. So see that my M is 2.6. I'm going to round, and I'm going to say my B is 65. So 2.6 and 65. So M is 26 and B is 65. Before I go ahead and write that stuff down, um, there's something here that you might not be familiar with. I'm not sure. This R value, this R value, the closer it is to one or -1, the better it is. Okay. When it's close to one, that means the data is a really good positive fit. When it's really close to -1, it's a really good negative fit. So this one is really good. 0.99 is extremely high. It's almost one. So this data is it's really, really nice. If you get a number like zero point 0.2, that's crap. So that's not good. That's crappy if it's that low. It's supposed to be high, close to one, or close to -1. So this one is really close to one. So I'm happy with it because it's a pretty good fit. So I know that I'm good here. It's a good linear fit. Okay. So that's just something to note. Okay. My M and and my B are my major concerns. So M is 26 and my B is 65. I'm going to round it. Okay. So Y equals 2.6 X plus 65 is what I'm going to write down. Let me just write that down. I'm going to bring you back to the notebook in a second. So that equation was Y equals 2.6x plus 65. Okay, let me get us out of Desmos and go back. Let me get us out. Let me share this. Okay, so we should be back into the notebook. Y is 2.6x plus 65. And yes, that's an approximation. And R was a good number. R was like 0.99, which means that this is a really good fit. Okay, it's a really good fit. All right, so there's my equation. Um, does the data show a linear relationship? By looking at it, yeah, it does. The dots are really close to the line, so it's a pretty good relationship. So the answer to A is yes. All right, I'm not going to write that down, but we get it. If so, write an equation of the line of fit and use it. Okay, here's the equation. There it is. Write the equation for the line of fit and use it to estimate the height of a person who whose femur is 35 centimeters long. So great. So I know, okay, let's see. I want to figure out the height of the person. So his height is unknown. Estimate his height. The height is unknown. So the person's height is unknown. His height is unknown. His femur length is known. It's 35 centimeters long. So his femur is 35 centimeters. Okay. Let's just look and see what thing is what. Femur length is X. So basically, X is 35. Height is Y. Well, I don't know what his height is. It's missing. So his height is unknown. Okay, I'm trying to find that. So the good news is this is really easy because I have an equation that's going to allow me to find this person's height. All I have to do is put 35, the femur length, into X because that's what the femur length is. It's X, and I can compute the guy's height, right, by doing this. So in other words, I can say Y equals 2.6 times 35, right? Because that's the equation we're using, plus 65. And yeah, we need a calculator. It's definitely going to be helpful for this. So let me just get a calculator. So, okay, here it is. Calculator's open. So in this question, it's 2.6 times 35, 2.6 times 35. 2.6 times 35, I have 91. And then I can add 65 onto that, which I'll do now. If I add 65 onto that, I have 156. So y is 156. And I believe the answers are in centimeters. Yes, they are. They're all in centimeters. Okay. So a person with a 35 centimeter femur has a height of 156 centimeters as an estimate. Let's just make sure that kind of makes sense. 35, 156. So 35, 156. Let's see if this coordinate is close to the line at least. 35, 156. So 35 is like here, and 156. Yeah, 35 would be here. 156. Yeah, that's 80. What is this? These are going by, this is 40, this is 120. This is 40, 120. So 156 is real close to 60, right? Yeah, it's like up here. It makes sense. Okay, that point is really close to that line. So it looks like it's in about the right place. All right. So that's basically how you handle this. You can just use the software. If you don't want to use Desmos because it's a little annoying, there's other software you could use. I'm just going to show you one more thing. You can just type in and let's do it together. So let me get you out of this section. Okay. And let me show you what I'm talking about. So just do a Google search and you can just do linear regression calculator or something like that. And then you'll see a bunch of things that come up. Okay. Quick linear regression calculator, social sciences, statistics. You can just click on that and then you get something like this. You put the X values in here, just type them all in, type the Y values that go with them in here, and then just hit calculate the regression equation and it'll do it for you. All right. So this is all free. You just go online, do a search, and if you don't want to use Desmos, you don't have to. Okay. You can use another free online program to do it. You don't need a Tier 83 calculator. So I'm pretty sure there are going to be people at home without the calculator. So and that's fine. You don't need it. Just use the computer and do it that way. That's fine. Okay. Are there any questions about anything? Anything at all? Anybody? We're good? That's all I really have it today, unless anybody has any questions. I just really wanted to show you, how to use technology to put these together. That's kind of the main thing. I just want you to be aware that you can do it that way, and even the first question I did with the prom, you could have done that with the computer too, but there was no need to because that one worked out. I knew that one had worked out really nice, so it wasn't a line of best fit, it was a perfect fit. So I didn't have to worry about using technology, but you could use it if you want to. Um, that's really all I have to say. There's an assignment due tonight, so please get that in. And the next assignment, I don't think will be due till next. I don't. Maybe you'll have something due Friday. I have to look. And other than that, that's about it. All right, I'm gonna stop the recording. Everything's complete. Please enjoy the rest of your day and be safe. And I'll see you tomorrow.